Okay, I want to turn your attention to what you see on the screen. Okay, you see a whole bunch of blue. You should be seeing a whole bunch of blue and green numbers, but you should actually probably aren't because I'm not sharing. But here we go. Now it's shared. Okay, so what the heck is this all about? Okay, rational roots. So let's say, okay, let's say you want to find the x-intercepts of this. Okay, let's say you want to find the x-intercepts of that. Now, of that equation right there. Now, let's say we live in a day, we'll live in a time where there are no such thing as graphing calculators or Desmos. Okay, how do you go about doing that? Okay, you can try factoring first. You can try doing something like this, factoring, to get you something, hopefully, maybe like, I'm going to completely make this up. 2x, x minus 3, 3x plus, I don't know, 5. And then you can get x equals to 0, 3, and negative 5 over 3. Okay, but the challenge here is that how do we even factor this guy? This one is not even obvious. There's no way to factor it. Okay, there's no way to factor this. Do you GCF out a 2, a 3? That doesn't work. Do they all have an x you can GCF? That doesn't work either. How do you factor this? Okay, the thing is you can't really factor this. Okay, so then what can you do? Are you going to try a whole bunch of synthetic divisions to see which one will give you a remainder of 0? Okay, so maybe you can do this. Okay, maybe you can try, I'm going to just take a guess out of thin air. I like the number 2. Okay, and then you go 10, 9, 19, 6, and then you pray to the math gods that this number is going to be 0 in the end, so that you can verify and confirm that 2 is indeed an x-intercept. Okay, that is a tedious process. So let's say 2 doesn't work. Let's say this is actually not a 0. Okay, let's say that's not a 0, and let's say instead that that's a 6 or whatever, a 7. Okay, that didn't work. Then do you try 3? Then you try 4? You try negative 1, negative 2? Dude, you're going to be in here for the long haul. Okay, that's going to be a long, long process. Okay, so let's narrow down which synthetic divisions to try. Okay, let's narrow down which synthetic divisions to try. Okay, so that is what the lesson is about today. Okay, the lesson is about what do we do if we live in a time when there are no graphing calculators and there is no Desmos and we have to find some x-intercepts. Okay, that's what this lesson is about. Okay, so and so from that, we try a whole bunch of synthetic divisions, but of course, trying a whole bunch of synthetic divisions, like you can go on forever and ever. Okay, so how do we narrow it down? Okay, so that is the key of today's lesson here. Okay, so let's go ahead and I am going to, let me show you guys this. Now, let me dock this to the left. Now let's say you have this. Okay, you're going to pay attention to this 6 first. That comes first. The last number is the one you pay attention to first, and you think about all the factors of 6. Okay, you think about all the factors of 6. And the factors of 6, basically, that's a fancy way of saying what numbers can be divided into 6. The answer is 1, 2, 3, 6. And there you go. Okay, and there's positive and negatives of it. Okay. And then you ask yourself, what numbers, okay, what numbers can be divided into 10? So your first number, the first number 10, you do last. Okay? and then it's 1, 2, 5, 10. Okay, those are the numbers that can go into 10. Okay, all right. So again, you're just asking yourself, what are the factors of the last number? Put that first. What are the factors of the first number? Put that second. Okay. All right. Now, let's look below here. Now watch this. How the heck did I get these numbers? Okay, how did I get those numbers? Okay. First of all, these are all fractions. Okay, these are all fractions. All right. Now watch this. This is actually really easy. It's just tedious, but it's easy. I'm going to shoot some laser beams. Okay, pew pew, some laser beams. Okay, I'm going to pew pew there, pew pew there, pew pew there, pew pew there. 4 laser beams. Boom. And that's how I got that. Okay, 1 over 1, 1 over 2, 1 over 5, 1 over 10. Okay, and that's how I got these right here. All right. Now watch this. I'm going to shoot some laser beams here. Okay. 2 to the 1, 2 to the 2, 2 to the 5, 2 to the 10. Okay. 2 to the 5 and 2 to the 10, and that's how I got these. Okay. And you just keep going. Let's jump over to the 6. It's the same thing with the 3. Okay, let's just seal the deal. Okay, and the 6, let's shoot some laser beams here. 6 to the 1, I want it orange, not yellow. Okay. 6 to the 1. 6 to the 2, 6 to the 5, 6 to the 10. Okay. And that's how you got that. Okay. Now, what the heck? So hopefully you guys understand how I got all these numbers / fractions. Okay, remember, this is 1 over 1, 1 over 2, 1 over 5, 1 over 10. So these are all the possible x-intercepts that you can have. Okay, these are all the possible x-intercepts that can exist. Okay, and then so we narrowed down a pool of 16 numbers that might be x-intercepts that we can try for synthetic division. Okay, so now, before, I should say, we used to have an infinite pool of numbers to use synthetic division with, which was super annoying. Okay, because we're going to be in here for years. Okay, but now we narrowed it down from an infinite pool to just a pool of 16. Okay, all right. Now let's be honest. Okay, even though Chen hooked it up and gave you 16 numbers to narrow down to, all right, let's be real. 16 numbers is still a lot. Okay, all right. Back in the days, my teacher actually made us do all of it. Okay, all 16 of these numbers and see which one worked. Now, guess what? It's actually not 16. Okay, it's double the quote-unquote fun. It's double the fun. It's actually 32 because there's positive versions and negative versions. So 1 over 1 positive is positive 1. Okay, if and then you also have 1 over 1, and if it's negative, that's negative 1. So you got to try positive 1 and negative 1 here. You got to try positive 1/2, negative 1/2 here. You got to try positive 0.2, negative 0.2 here. And that, folks, is super annoying. Okay, so what we're going to do, okay, I'm going to give you a shortcut because I want to keep this Chen train moving. Okay, we're going to cheat a little bit. We're going to actually put this on Desmos, okay, or your graphing calculator. But for today, you can use Desmos. I would actually prefer that you use your graphing calculator, especially if you're going to take AP Calc next year. But for this one, I really don't care. Okay, it's just a little preference. What was that? 10, 9, negative 19, 6. Wow, geez, I cannot type today. 10, 9, negative 19, and 6. Thank you, Devin, for telling me that right away. Okay, now I just type this in on Desmos, okay? And if I zoom in, ooh wee, look at this. I get a -2, a 0.5, and a 0.6, okay? So I'm going to write that down here. I'm going to write down -2. This is from Desmos. I'm going to write via Desmos. Let me erase all this stuff going on over here. Okay, it's just this is just unnecessary. Okay. Now via Desmos, there was -2, 0, 0.5, 0, and 0.6, 0. Okay. So -2, 0, okay, -2, 0 is going to be right over here. Let's see, I'm going to do it in black. Oh, good call. Thank you again. Okay, so I just copied the x-intercepts from Desmos here. Okay, that's the x-intercepts from Desmos, and I'm just going to confirm it over here. That's all I'm going to do is confirm it. Okay, I'm going to confirm it. So I'm going to go, watch this, the -2, where is it? There's no -2 here. That's 1 over 1. This is basically positive -1, positive -0.5, positive -0.2, positive -0.1. So where is -2 at? -2 is right over here. Okay. Let me get rid of these. Let me get rid of these circles here. Okay, the other orange, red, and green. Okay, the -2 is right here. All right, I'm going to write -2, 0. Now, where is the 0.5? There's a 0.5 right here. Okay, 0.5, 0. All right. There's nowhere else there's a 0.5. That's it. Okay, so there could be multiple places for each one of these x-intercepts. 0.6, here you go. Here's the 0.6. All right. Is there any other 0.6s? Okay, just make sure that that's, yep. Is there any other point? Yep, there's a 0.6 right over here. Okay, 0.6, 0. All right, and that pretty much is the gist of this lesson. Okay, so just circle, just use your, so go ahead, so here are the steps. Okay, I'm going to add one more step of synthetic division in a little bit, but I'll mention that in the end. Okay, so your last number goes first, first number goes last. Okay, I should say first number goes on top. Oh my goodness, I'm mixing it up. Last number goes on top as your numerator. First number goes on bottom as your denominator. Start shooting some laser beams. Okay, start shooting the laser beams, like the 1 to the 1, 1 to the 2, 1 to the 5, 1 to the 10 gives you that, and so on and so forth. Okay, and you create all these fractions, plus and minus versions. You don't even need to write the plus minuses. It's just understood. Okay, because that's even more annoying than this already is. Okay, and then go on Desmos, find the x-intercepts, write them down. Okay, just write them down as a side hustle, and just start circling where you see them from this pool. Okay, from these pool of possible x-intercepts. And the last thing I want you to do, okay, is confirm that these work. Okay, confirm that these work. Okay, using synthetic division. Now, does that mean you're going to do 4 synthetic divisions in a usual face-to-face learning non-COVID situation? Yes. Okay. However, we got to keep the ball moving a little faster in this particular class with distance learning. So I'm just going to have you guys confirm one time with synthetic division just the least x-intercept, and the least is going to be -2. Ooh, man, you guys got lucky that it was not a fraction, okay, or a decimal. Not that it's a big deal because you guys don't know how to handle that. 10, 9, -19, 6. All right, I'm just going to do this fast. -20, -11, 22, 3, -6, 0. Okay, smiley face. That's it. Okay, and that is how you do these problems over here. Okay. Okay, go ahead and do the next problems that I'm going to show you.